Hello dear students, welcome back to another lesson. In this lesson we're going to start chapter 4, as many of you asked me to explain chapter 4 and continue until the end of what's included for Wizari exam. In chapter 4 it's about the applications of differentiation. Application of differentiation are so much, but here in grade 12, especially in this book, we study some of them. We begin with 4.1, which is about first derivative test. Using the first derivative, we can find critical value, which is going to be maximum or minimum based on first derivative test. And we can find intervals of increasing and intervals of decreasing. Let's have a brief explanation on this graph. We always look at graphs from left to right. We always look at every graph from left to right. This graph from left to right, it's going up until here. So since the graph is going up, we call this interval increasing. And when an interval is increasing, f prime is going to be positive. The opposite is also right. If f prime is positive for some interval, then this interval is going to be increasing. That means from left to right, it's going up. Similarly, if the derivative is negative for some intervals, then those intervals are going to be decreasing. And the opposite is also right. If an interval is decreasing, f prime is going to be negative. And when f prime is equal to 0, this is where the critical values happen, and the critical points that are going to be maximum, minimum, or just critical, which is not max or min, it's just a critical value that makes the derivative equal to 0 or undefined. Let's apply what I said on an example. The first example in this regard in the book is this: x power 3 minus 3 over 2 x power 2. Let's solve this one. Find intervals on which the function is increasing, decreasing. Alright, to find intervals when a function is increasing or decreasing, we find derivative first. So we begin with f prime x is derivative. Derivative of x power 3 is 3x power 2 minus 3 over 2 multiplied by 2x power 1. 2 cancels 2. So what we have is 3x squared minus 3x. This is the derivative. To find critical value, to find intervals of increasing, decreasing, to find horizontal tangent, to find maximum, minimum, or extremum values, to find any of these that I just said, we set derivative equal to 0. So 3x squared minus 3x equal to 0. Now to solve this, since both terms contain 3 and x, I can take 3x as common factor. What's remaining is x minus 1 equal to 0. From here, what makes 3x to be 0? X equal to 0. And from here, what makes x minus 1 to be 0? X equal to 1. Now I have two critical values. I'm going to make a table. The table contains x, f prime x to see if it's positive or negative, and fx to see if it's increasing or decreasing. These numbers, we always write the smaller one on the left, the larger one on the right. Here on the left side of 0 we have negative infinity, on the right side of 1 we have positive infinity, and between them we're going to take a number for testing, let's say 0.5. This is a test number. I'm going to put it in a square So later by mistake, I'm not going to write 0.5 in any of the intervals. Less than 0 is negative infinity, but I cannot input negative infinity here. Then I'm going to choose a number that is on the left side of 0, let's say negative 1. And on the right side of 1, I'm going to choose 2. Always put these test numbers in squares like this. So by mistake, you don't write these in the intervals of increasing, decreasing, because these are numbers just for testing if the derivative is positive or negative. We don't need the numbers themselves. Now, f prime of negative 1 is 3 times negative 1 squared minus 3 times negative 1. This is 3, and this is also 3. The result is positive 6. I don't need the 6. I need only the sign. So here is positive. That means the function in this interval is increasing. These arrows, we always draw them from left to right. This is increasing. This is decreasing. We don't have any other type of arrow. Don't do something like that representing increasing. That's wrong, because this is from right to left. We don't want that. We only want it from left to right. Now, let's input the next test number, which is 0.5. So f prime of 0.5 is equal to 3 times 0.5 squared minus 3 times 0.5. If we do this, remember to use calculator since it's allowed. 1 minus can change your life, can change your university. 3 bracket 0.5 close bracket squared minus 3 bracket 0.5. The answer is negative. So the function in this interval is decreasing. And after that, for 2, it's going to be 2 squared times 3, 12. 12 minus 6 is going to be positive, and positive is increasing. Now, if we write the intervals, interval of increasing interval is 2 pieces. So look at here, how do we write them? From negative infinity until 0 is increasing, union with, there is another piece of increasing, which is from 1 until infinity. Now, decreasing is from 0 until 1. In chapter 4, every single interval of increasing and decreasing we write, the brackets are always open. Then the first example is complete. Second example, the question again says find the intervals on which this function is increasing or decreasing. Okay, now you know, since the question is about increasing, decreasing, we're going to do the first derivative. The first derivative here is 3x power 2, 3 cancels 3, that's only x squared remaining. And here it's going to be 2x, 2 cancels 2, only negative 3x is remaining. And the derivative of 9 over 2, which is a constant, is 0. Then this is f prime x. Then we set f prime x to be equal to 0. So x squared minus 3x equal to 0. Take x as common factor. So x minus 3 is remaining. This gives two answers, x equal to 0 or x equal to 3. Now we're going to write these two numbers, 0 and 3, into a table. 0 on the left, 3 on the right. Then we're going to choose some numbers for the test. Between 0 and 3, we choose 1, it's in a square. More than 3, let's choose 4. Less than 0, let's choose negative 1. Then when we input these numbers into the derivative, f prime negative 1 is positive. That means the function in this interval is increasing. F prime of 1 is negative, the function is decreasing around 1, and f prime of 4 is positive, that's increasing as well. Now you might ask, how about these, f prime of 0 and 3? We already solved for them f prime of 0 and f prime of 3 are at 0 because they are critical values. But what is the value of f? Value of f, we can input 0 into fx and get the result, and for 3 the same. These two critical values, one of them is maximum, one of them is minimum. What's the difference between them? The point that forms the arrows in this way, this point is maximum. The point that has the arrows in this way, this point is minimum. Now you can guess here which one is maximum, which one is minimum. This is max. Whatever result it has, it is maximum, and this is minimum. Critical points occur at two cases. Case number one, if the x value makes the derivative to be equal to 0, or if the x value makes the derivative undefined. In these two cases, we have critical values for x. And there is another thing. When we have sharp corners, we have some graphs with sharp corners or cusp where derivative is undefined. And at these sharp corners, derivative is undefined, so the sharp corners are going to be critical values. So for the graph of negative absolute value of x, negative absolute value of x has a graph, an upside down V shape. The absolute value has x inside, so if we write x equal to 0, this is directly answer. We don't need to simplify it anymore. Then this x equal to 0 is the critical value. This critical value according to this graph is maximum. And if we want to mention intervals of increasing and decreasing, from negative infinity until 0 it's increasing. From 0 until positive infinity it is decreasing. So for absolute value, it is a very good idea to graph the function, and then you don't need to do derivative equals 0, simplify, find critical. No, once you graph, the sharp corner is critical value, and if it's the highest point in the graph, then it's maximum. Or if the V shape is like this normal, then this point, which is the lowest point in the graph, is going to be minimum. So at sharp corners, derivative is undefined, so sharp corners are critical value. Is the function continuous at 0? Yes, the function is continuous. It has limit is 0, but it does not have derivative. Let's solve another example that has a lot of critical points. This example, we begin with derivative f prime x. As you see, the function is rational. We can directly use the quotient rule, or we can multiply 9 by inside and then use partitioning. Both ways are okay. Let's put 9 inside the bracket. X power 3 is in the denominator. This is 9x power 2 minus 27. Now if we apply quotient rule, denominator power 2, x power 3 becomes x power 6. Denominator is x power 3 multiplied by derivative of numerator, that is 18x, minus, this time numerator stays the same, derivative of denominator is 3x squared. This is quotient rule. We can simplify this. X power 2 is common factor. We have x power 2 here. Since this bracket and this term are multiplied, we consider them like one single term. So this x power 2 is common factor. Here we have x power 3. So we can take x power 2 as common factor. What's remaining here is only x. X times 18x is 18x squared. This minus goes to both terms. That is negative. The 3 stays. 3 times 9 is 27x squared. With the negative, negative 27x squared. And 3 times negative 27 is negative 81. With this negative, it's going to be positive 81. All over x power 6, there is cancelling. X power 2, x power 6 cancel out each other. X power 4 is remaining in the denominator. Now we have the derivative. As you see, these numbers are all divisible by 3. If we divide them, it will be 6x squared minus 9x squared. Yeah, then we add the like terms, plus 81 divided by 3 is 27. All over x power 4. We can collect the like terms. 6 minus 9 is negative 3x squared plus 27 over x power 4. What makes this 0? Negative 3. That's the derivative equal to 0. So the numerator, negative 3x squared plus 27 equal to 0. 27 to the other side. 3x squared equal to 27. This will be negative. This will be negative. This is already negative. So the negatives cancel out. Divide by 3. X squared equal to 9. That means x is equal to positive negative 3. X equal to positive negative 3 are two critical values. Another point or another way of finding the other possible critical values is to solve denominator. We already solved numerator. We got two answers. Now you're going to solve denominator. Denominator is x power 4 equal to 0. Directly x equal to 0. This x equal to 0 makes the derivative undefined. Now we need to test that to see if it makes fx undefined as well. So if we input 0 into fx, this is going to be negative 27 over 0. F is also undefined at x equal to 0. That means this x equal to 0 is vertical asymptote, but we still write it in the table when we check intervals of increasing and decreasing. Now let's say that again. Critical values that make f prime 0 or undefined go into the table, and vertical asymptotes go into the tables. Now we have three numbers, negative 3, 0, and positive 3. Let's write them into a table and then test if the intervals of increasing are and decreasing are there. Table x, f prime, f. The x's are negative 3, 0, 3. More than 3 is infinity. For testing, I want to choose some numbers. Less than negative 3, I want to choose negative 4. Between negative 3 and 0, negative 1 is good. Between 3 and 0, 1 is okay. More than 3, I want to choose 4. Let's input all of these 4 test numbers into the derivative. This is the derivative. Then let's see if the result is positive or negative. I use calculator. Negative 3, bracket, negative 4, close bracket, power 2, plus 27, equal to negative. Denominator is x power 4. If we input negative, the result will be positive. So negative divided by positive is negative. This interval is decreasing. As I said before, we only need the sign. We don't need the result. Now for negative 1. If we input -1 into the derivative, -1 makes the numerator positive and denominator will be positive as well. That is positive increasing. If we input 1, -3 plus 27, that is positive, divide by positive is positive. So around the vertical asymptote, both sides are increasing. More than 3 is 4. 4 squared is 16. -3 times 16 will be more than 27. That is going to be negative, decreasing. Now intervals of increasing are from -3 to 0, -3 until 0, union with 0 until 3. Never write these as one interval, because 0 inside this interval makes the function and the derivative undefined. So 0 should not be into the interval. So I wrote it as 2 pieces, and these 2 pieces are only ignoring 0. This one says from -3 until 0, 0 not included. This one says from 0 until 3, 0 not included. This is the interval of increasing. Intervals of decreasing are from -infinity until -3, -infinity until -3, union with another interval of decreasing is from 3 until infinity. Now I found all the intervals of increasing and decreasing. If we identify these two critical values, this one is going to be minimum, the point that contains -3 as x, and the result of f of -3, whatever it is, this point is minimum, and the point 3, f of 3 is going to be maximum. This makes an upside down V shape. This makes a proper V shape. That is minimum. This is maximum. That's enough for this lesson. Thank you so much for watching. Stay tuned to see the rest of the book. In the next lesson, we're going to solve the exercises of section 4.1. Thanks for watching.